I bet you never thought there was a connection between
mobile phones
fast cars
and emptying your bath.
Nah, you're never going to get it. It's straight line graphs, of course.
And that's what today's programme is all about. Straight line graphs, what they mean to you both in your maths exams and in the real world.
Come on.
Somebody answer the phone.
The high street is full of mobile phone stores offering all kinds of deals.
Yeah. Right, wow.
But a bit of maths and a couple of straight line graphs will help you choose the best offer.
Somebody answer the phone.
Mobile phone deals are a minefield. There are so many different offers and different conditions. To keep it simple, we're going to be looking at two made-up mobile phone deals, comparing them using straight line graphs. Now, Deal A has a weekly line rental of £5 and calls are charged at 10p per minute. And Deal B has no weekly line rental, so it sounds pretty good, but calls are more expensive. They're charged at 25p per minute. First of all, let's see what Deal A looks like as a straight line graph. All graphs have two axes. Here, the horizontal axis, or x-axis, is where I'm going to record the call time in minutes. And the vertical axis, or the y-axis, is where I'm going to record the total cost in pence. It's best to plot 3 points, and you can work these out from the call rate. First of all, let's say that our first point is going to be at 0 minutes. For 0 minutes, the call charge is £5, or 500 pence. For 20 minutes, the call charge is £7 or 700 pence. For 40 minutes, the call charge is £9 or 900 pence. Plot the points and you get a straight line.
This is the straight line graph that Katie's just drawn. It's a graph with a line that looks pretty straight to me, but there's more to straight line graphs than meets the eye. In maths, a straight line graph can be represented by a general equation which is always the same, and it's this: y equals mx plus c. Y and x are the coordinates of the points. Their values change along the line, but the values of m and c are fixed. M is the slope, or gradient of the line. It's the number that x is multiplied by. On this graph, for every 10 units in the x direction, the graph goes up 100 units in the y direction. Or, for every 1 unit in the x direction, the graph goes up 10 units in the y direction. For this line, the value of m is 10. So we can put that into the equation. C is the value of y when x is 0. It's where the line crosses the vertical y-axis, which on this graph, as you can see, is 500. So the equation for this straight line is y equals 10x plus 500. And that's it. All you need to know about straight line equations. Straight up.
This is the graph for Deal A. Now let's look at the graph for Deal B. Deal B is the one where line rental is going to cost you nothing, but calls cost 25p per minute. So if you don't use it, the call time X is 0 minutes, and no line rental means the cost Y is 0 pence. 20 minutes of call time costs £5 or 500 pence. 40 minutes of call time costs £10 or 1,000 pence. Plot the points and you get another straight line.
This is the new graph that Katie's just drawn. It's a straight line like the first graph, but this new line has a steeper slope and starts at a different point on the vertical y-axis. This means it has a different equation. Remember, for any straight line graph, the general equation is y equals mx plus c. Again, y and x are the coordinates. They vary. And m is the gradient. On this graph, for every 10 units in the x direction, the graph goes up 250 units in the y direction, which is the same as saying for every 1 unit in the x direction, the graph goes up 25 units in the y direction. So the gradient is 25. But what about c? Remember, the c is the value of y when x is 0. It's where the line crosses the vertical y-axis, and for this line, that's at the origin. Here, y equals 0. That means that c also equals 0, so we can stick that in as well. 25x plus 0. But that's stupid, it's just 25x, so we can take that off. So the equation for this straight line is y equals 25x. In fact, if you're given an equation for a straight line without a plus c bit, then you immediately know that it cuts straight through the origin, which is a handy little straight line hint.
Now that I've got my two straight lines plotted on this graph, I can finally use them to compare the two mobile phone deals. Instead of working out the cost for the call time on each deal, all I have to do is read off the graph. Now remember, our Maths for Real deal A was this one, where line rental was £5 a week and the calls cost 10p per minute. And the Maths for Real deal B was this one here, where there's no weekly line rental and calls cost 25p per minute. Ooh, which one are you going to choose? Well, let's look at the graph again. Say I wanted to find out how much each deal was going to cost me if I only made 10 minutes of calls each week, because obviously all my friends would be calling me, I wouldn't have to call them. All I do is I go along the horizontal axis to 10 minutes, and then I read up until I meet the lines. So that's where I hit deal B, that's the blue line. Going along to the vertical axis, I can see that the cost of the calls is 250 pence, or £2.50. So that's how much it would be for 10 minutes on deal B. For deal A, it's the red line, reading off the vertical axis, that's 600 pence, so that's £6. So obviously the best deal, if I was only going to make 10 minutes of calls a week, would be deal B.
So what happens to the cost at the point where the lines cross?
So far, we've only looked at graphs with positive x and y coordinates. But in maths exams, you might be asked to plot points with negative coordinates too. If the value of m stays the same, but the value of c changes, you get a whole family of straight lines. This is y equals 2x plus 1, y equals 2x plus 4, and y equals 2x minus 2. The gradient stays the same, but the point they cross the y-axis changes. If c stays the same, but m changes, see what happens. This is y equals 2x plus 1, y equals 3x plus 1, and y equals a half x plus 1. The lines all cross the y-axis at the same point, but the gradient changes.
Now, you might be wondering what emptying a bath has got to do with straight lines. Well, as the water empties from the bath, the volume remaining decreases. And that means, in other words, that as time increases, volume decreases. So now I've explained that to you, why don't you go off and have a look at a graph or something before this water gets too low. Go on, off you go. See ya, off you go. Here you go. Oi, out, now, go on.
Ben's bath started with 150 litres of water and empties at a rate of 75 litres per minute. A graph of water remaining against time looks like this. C is 150. M is negative 75, because for every 1 unit in the x direction, the graph goes down by 75 units in the y direction. Because it slopes downwards like this, the gradient is negative.
Ford was a genius. This is the 1967 Mustang, 260 cubic inches of throbbing muscle under the bonnet. I've got enough room in here to get in the whole population of Detroit and still have room for the kitchen sink. Fuel consumption, 0 to 60, who cares?
But if you want really hip, if you want really trendy, and you want really now, then you want to try one of these babies with curves as sleek as Lara Croft thighs. The Reliant Robin is the car to pull in the new millennium. You may laugh, but this little baby's fuel consumption is far better than Katie's Mustang, and let me tell you, it goes from 0 to 50 in about, 2 weeks. Come on.
Now, on the back seat of this car, I've got a nifty little machine that measures fuel consumption. We need to know just how much gas this baby can guzzle. Now, for both cars, we're going to be measuring distance travelled and the amount of fuel remaining in the tank. And we're both starting with exactly 15 litres of petrol.
Now, if we plot fuel remaining against distance travelled, then we're going to get a straight line graph. The question is, what's the graph going to look like? The graph for the Mustang will be different from the graph for my Robin Reliant, but there will be some similarities. Now, while we're collecting our data, see if you can predict what the graphs are actually going to look like.
All we need to do now is drive at the same steady speed around our test track, and at the end we'll be able to see whether our cars are sipping or gulping. Let's go!
These are our fuel consumption graphs. Similarities? Well, both start at the same point and both have negative gradients.
But my Mustang straight line graph is a lot steeper than the one for the Robin Reliant, and that's because the Mustang is using up petrol at a much faster rate.
It's that part of the programme when Ben and I both tackle a maths question, but only one answer will be right.
The other will contain a deliberate mistake that you've got to try and spot. So watch carefully and decide, do you tick it or trash it?
Today's question is about straight line equations and graphs.
We have to make a table of values for the equation y equals negative 2x plus 3 and then draw the graph y equals negative 2x plus 3 on the grid provided. Pen set? Let's go.
Make a table of values for the equation y equals negative 2x plus 3, and then draw a graph of y equals negative 2x plus 3 on the grid provided.
Here's my graph for the equation y equals negative 2x plus 3. The key to drawing a straight line graph is to plot at least 3 points. So I looked at the sides of the grid and chose these 3 values of x here. Negative 2, 0, and 2. And then I found the corresponding values of y. So when x equals negative 2, y equals 7. When x equals 0, y equals 3. And when x equals 2, y equals negative 1. I then plotted the 3 points on my graph and drew a straight line through them.
Like Ben, I worked out 3 points. Now the values of x I chose are 0, 1 and 2. So when x is 0, y is 3. When x is 1, y is 5. And when x is 2, y is 7. I then plotted these points on my graph and drew a straight line through them.
Which graph will make the tick flash and which one's headed for the trash? Whose working out was correct?
Does Ben have the correct table of values?
Or does Katie?
OK, it was my graph that was wrong. I've got a straight line, but it slopes in the wrong direction. That's because I completely missed out the negative sign when I was substituting values for x in the equation. I multiplied my x values by 2 instead of negative 2. Remember, the general equation for a straight line, y equals mx plus c, gives you a major clue as to what the graph will look like. When m is a negative number, that's the number in front of the x, the straight line always slopes backwards. When you've drawn your graph, it's worth checking that it fits the original equation.
Another useful tip is to choose a good spread of values for x when you're filling in the table of values. If there are negative values on the grid, then choose a negative value, 0, and a positive value.
Katie, I'm so excited. I'm driving a 1967 Ford Mustang drop top. The sun's shining. We're going to journey home. You did remember to put petrol in the car, didn't you?
Yeah.
Katie, what's going on?
I'm sure I put petrol in. I'm sure I put
What
petrol
have
in.
you forgot?